The following presentation was made by John Frensley at World's Finest Physics.
As we continue going through rotational motion, it's now time to look at rotational inertia, also known as the moment of inertia. We're going to be learning how rotational inertia affects an object's motion, specifically rotation. We need to be able to define rotational inertia and state what this property depends on. We are also going to be able to describe how an object's rotation is affected by its rotational inertia, and we'll be able to make predictions about rotational motion based on rotational inertia. Now it's time for some vocabulary. Inertia is the measure of how difficult it is to change an object's translational motion. The resistance to move is inertia. It's not a force, it's just the resistance, the natural resistance to move. Inertia is the same thing as mass. Rotational inertia, a measure of how difficult it is to change an object's rotational motion. The symbol we use for rotational motion is I. Capital I, to be specific. The units for it are kilograms times meters squared. The basic equation is I equals some constant times the object's mass times the distance from the pivot point that we're looking